Welcome and thanks for joining the School of Ops. Today we're going over troubleshooting in vRealize Operations Manager. A little bit on the agenda, what we're going to cover. We're going to go into metric and inventory navigation. We'll go into the metric picker and metric chart widgets, so all of the options that are available there for metric pickers and the corresponding metric charts. We're going to go into dynamic thresholds and anomaly detection. There will be a section on metric correlation. There is then going into the Troubleshooting Workbench. So we'll cover events, property changes, and anomalous metrics, what each of those are and kind of what they're used for. There is a section as well on what the difference between anomalous metrics is and a metric anomaly. It's kind of a subtle difference in naming convention, but they are different. So we'll go get into what is the differences between those anomalous metrics and what makes a metric anomaly versus if it goes into and changes a metric enough that it becomes an anomalous metric. Also the scope on the Troubleshooting Workbench, so what that scope is, how we can increase or decrease that scope or use any sort of a custom scope for our troubleshooting sessions. And then finally a section on near real-time monitoring, what that is and how we can utilize that to get a little more granular into our metrics that we're looking at. So why is troubleshooting important? Well, vRealize Operations does help manage health, risk, and efficiency of the environment, and it's going to give you context-specific alerts and recommendations. There is a section on alerting and out-of-the-box alerts and reports within the School of Ops as well. But at times we will need to discover root cause and resolution of any occurrence using our built-in tools to help solve the current challenge. Now that might be using an alert or using some of the other tools that we'll cover here in this section. Going into kind of what we're discussing right here is the troubleshooting process. What does it take for us to understand that there is some sort of an issue or challenge we need to solve to the point where we can solve it, and we can use our AI or machine learning to reduce our mean time to resolution, our mean time to innocence, and use this process and use all of the built-in tools that vRealize Operations has in order to work through this process from start to finish. Right? We need to know that there is some sort of a challenge or some sort of an issue in the first place. Might be an alert, phone call, right? Hallway conversation, water cooler conversation, whatever it might be. We need to know that there is something that's ongoing that we need to solve. Investigation going into our time and frequency, meaning is this a one-time spike, or is this something that's reoccurring over and over again? What is the scope of our change and the scope of our actual troubleshooting session? How exactly how can we find that information? We'll get into, as well as the history then. Is this, again, something that is recurring over and over, or is this something that is just this challenge we're looking at, just something that just popped up? We're going to review certain things, metrics, events, logs, and knowledge-based articles. So there's plenty of places we can show that we will show here in this session of where we can look into our events, our metrics, whether that be anomalous metrics, anything, any anomalies that pop up with any of our metrics, as well as any of our knowledge-based articles that might go into. We're using vRealize Log Insight to help us with reviews and logs. Then we go into, what now that we've kind of found out what this is or what the challenge might be. We need to look at what our potential evidence might be to help us decide what our root cause is, or the resolution we need to take in order to fix this. That might be through an alert or a recommendation that comes from an alert. And that recommendation could say we need to change the vCPUs or change the memory. Maybe we need to change some disk space so we have some more storage space. Or maybe do some sort of vMotion, some sort of migration in order to manage our workloads better. And then once we've figured out what we need to do, we have our resolution, of course, test, document, implement, monitor, all of those things we need to do to make sure we don't continue having challenges or the same challenge again, and then we are finished with that particular troubleshooting process. So let's go ahead and get started. We're going to jump into it and get logged into this real quick here. All right, so we've gotten logged in. We're coming into the home screen here. Now we can see this third pillar on the right side here is going to be our troubleshooting pillar. And so it is going to have launch points of where we can get into either Troubleshooting Workbench, look directly at alerts, logs, as well as dashboards. If we want to troubleshoot by object type, that'd be virtual machine, hosts, clusters, data stores, our vSAN objects, or any applications that might have been discovered either by vRealize Network Insight or applications we've created directly in vRealize Operations Manager. For today, we're just going to go ahead and look at a specific VM. We've gotten a call about a VM having maybe some troubles every once in a while, and we want to look at that a little closer. So we're going to go ahead and look at this particular virtual machine, and we know this particular virtual machine does or is part of our application shopping cart or our shopping cart application. So we know we need to keep that, make sure we keep that up. We're going to go ahead and go to metrics first of all. And we can see within our metric picker options here, we have a couple different options. We have our favorites, so that the most commonly used or our commonly used metrics we have here. Any and all metrics is going to be under the metrics portion here. We have any super metrics that might be created. So any that we've super metrics that are here, we can always look at those super metrics as well. Any properties of that particular virtual machine, and if we've got any sort of tags set up for that machine. I'm going to go ahead and I want to look at first some CPU options here from this particular virtual machine. So let's pick out contention, let's get demand percentage, and then let's go with usage percentage as well. So we can see the three different options we've got here have popped up since we've double clicked them. So now we've got our contention percent, our demand percent, and usage percent. Demand and usage probably going to be fairly similar in this case, but of course doesn't always have to be. So the first option we have that's available to us is split charts, and that's what we've got now. We've got those charts that are split, and if we unclick that, we then can get everything kind of on one chart. That doesn't look so great. We can't even see our demand percentage. What if we click this little stack chart button here? That's what this button does. We'll see that we can read this a little more often or a little easier. Now we can see our usage and our contention and our demand all on one chart. And we got a couple spikes we might want to look into. We can also zoom these in if we wanted to see a little closer on what's going on with any particular metric. And if we want to get back to the way we had it, we click that split charts again, and we're right back to where we were. Jumping out of our demo environment for a moment, I want to go over the next chart option. Before we get into that, we probably need a little bit of background here on what that is. So we're talking about dynamic thresholds here. Of course, we can set hard thresholds for any of our objects in vRealize Operations Manager, for CPU percent, memory percent, whatever it might be. But we would get an alert every time that hard threshold is breached. So what about when we take our backups every night or every week, whenever it might be? It's going to fire that same alert every time. So we're going to get that alert every time we run backups or any other little spike that might happen that we know is going to happen or is commonplace. What if we change our resources on that object or what that object is utilizing? Well, now we have to go back through and change all of our hard threshold, or we might get a bunch of alerts getting fired off again because we've changed our resources, which is going to go through notification channels, right? It might get emails or it might go to Slack or PagerDuty, something like that. So it just becomes noise, and noise can be easily ignored, right? If we start ignoring alerts that are coming through because every time an alert or every time a metric breaches a hard threshold, we might miss something that's important if we start kind of ignoring that noise. So we came up with this concept of dynamic thresholds, and what this is the back end on vRealize Operations Manager. The machine learning is learning what is normal for a selected resource, and it's going to let us know, if that we run backups, say every time every week, or say every Tuesday at 3 a.m. And something spikes up at 3 a.m. We know, hey, that's normal. The machine learning here will calculate this is a normal thing, and not we don't need to send an alert for that particular metric. So it is calculating what is normal for a resource, and then saying, all right, we're going to only get a send alert if a metric breaches that specific dynamic threshold. This threshold is calculated every 24 hours. You can change the time when these are calculated. You can disable completely. You can do that through the global settings within the administration vRealize Operations Manager. And this is also predicting out into the future on what these metric thresholds should be, or the projected amount they should be. So to our chart option, when we're looking at our metric pickers and our metric charts, here we have those buttons there. We can show or hide the dynamic thresholds, and we can show or hide for the full period on the graph that we're looking at. So there's once we've added that dynamic threshold, we can see there is one breach that we probably got an alert for, but most of the time it stays within the range here. And this is based on historical and incoming data. We can also calculate outside of the normal schedule. So if we go to administration, then to support, and then dynamic thresholds, we can start that calculation. We can stop that calculation at that point. So now we can trigger alerts for spikes or longer breaches. So it doesn't necessarily have to be just a little blip that pops up here above our dynamic threshold. It could be for a longer period of time as well. So back into our demo environment here, we're looking at the same metrics that we were before, contention, demand, and usage percentage of this VM. And we can see that there are a couple spikes here on our demand and our usage. Now, these aren't very high numbers as we're looking at, but if we wanted to find out if these are normal for this VM or if they're within the normal range for this VM, again, here's where we can use these dynamic thresholds. So we can turn these on real quick and see that down here under demand and usage, these are definitely within our range. Looks like we're between demand and usage. We usually go up to about a little over 10, and if anything jumps over 10, that would be outside of the norm here. So even though we do have these spikes, we're still within the normal range here of our dynamic thresholds. For looking at dynamic thresholds on the contention, however, we can see also still not a super huge number, but we are kind of getting closer to this dynamic threshold range here. We're looks like maybe trending upwards. Now there is an option we can use to look at that overall trend line. We'll talk about here in a moment. But for now, we're just looking at these dynamic thresholds. One last thing to talk about is that if I zoom in here, we can see here's where our data points end. And this is current time, where we are currently. Now, if we wanted to look further, we can see these dotted lines, these dashed lines that go out for our dynamic threshold. And it's a little bit lighter gray. Hopefully, we can pick that up a little bit on the video. But what that is the dynamic threshold then is projecting out if we think there's going to be any sort of changes for the future in this particular metric we're looking at. And since we've been within that range, our dynamic threshold range, we don't have any breaches here. vRealize Operations is kind of using our analytics engine in the background and saying we don't expect there's going to be any sort of change in the range or the normal range for this particular virtual machine. If we zoomed in, obviously, on the same metrics down below, yep, we're always within this range. We don't see any sort of change. That's why we're seeing kind of flat line here from a future perspective. Now, the next option I want to talk about here is the trend line option. So we have a couple different metrics pulled up at the moment. And what we can do is kind of see if we're trending upwards, trending downwards, or if we're just kind of maintaining. So that's this button right here. We're going to hit that trend line, turn on our trend line, so now we can see the kind of moving average for all of our metrics as we go through. So we can see it get contention. Looks like it's just kind of a little bit wavy here, but overall seems to remain pretty flat there. Good demand, pretty flat overall. CPU ready as well, kind of wavy. If we look at disk space used, we can see we do have a definite upward trend. It's not a huge jump, but it is that trend. So we're looking at those yellow lines that are running there. So this does work well when we're looking at longer time ranges, or it's especially great when we're looking at longer time ranges to see what a particular metric is doing over a longer period of time. And if we wanted to see it kind of zoom in a little bit and see just on a specific spot maybe, we can say, all right, let's zoom in right on maybe this little low period here. And that's we're using the zoom chart option here. That is this button here. We're just zooming the view, but we can notice that it did only zoom this one chart, and we do have this valley that came in here, our contention, but overall didn't affect our trend line. Now if we did want to zoom all of our charts, So I'm going to reset that zoom here. There's a button next to it that's zoom all of our charts. So we're going to click that, so make sure that's enabled. And now when we go ahead and look at the same little valley we were looking at, now we're going to zoom all of the charts in so we see our same time range over all of our metrics. So that's great if we wanted to say we want to look at a certain spike and see if that managed across all of our metrics, or if we just wanted to zoom in, of course, just one of our charts, we can certainly do that as well. And we can also go ahead and use this reset zoom, and we'll reset all of our charts back to the current time range. Now, if we did want to change our time range, there are a number of date controls we can use. So I'm going to turn off the trend line just for now at the moment. So if we want to go over here, we've got that little calendar looking icon here, and those are going to be our date controls. So if I click on that, it brings up a little pop-up here, and now we can change our range. Right now we're at last 6 weeks, but if we want to change it, so maybe we're just looking at the last 24 hours, we can certainly do that. Of course, we can go to last hour all the way up to last year, so we can get a very short amount of time and just get the last hour, or we can go all the way out to a year. And I'm going to click go on the last 24 hours. So now we see all of our charts just giving us information for the last 24 hours as we go through. We can also do, if I pull this back up, we can also say, all right, we were on the last 24 hours. What if I want the 24 hours before that as well? So I'm going to say the previous period. So we've got the last 24 hours and the previous period before that. So that'll bring in 48 hours and 24 hours. And we're going to click go on that. And now we can see, we can compare now. That's what this is great for, is comparing between our period numbers here. So we can say I want 24 hours, 24 hours before that. And now we can say, all right, has there been any big changes in these metrics in the last 48 hours total is what we're looking at. And if we wanted, we could also add in a third. Maybe we want the previous day as well. So now we're going to bring in 3 days worth of information. And now we can compare that as well from the first period, the second, and the third. And we can still use all the rest of our options. If we want to zoom in on any spots, we can still do that as well. Now we can also not just do the 24 hours, but if we wanted to do some sort of a custom range, we can do that as well. So if we wanted to say, I want to compare the last 24 hours, but I want to compare it to a specific date, we can certainly add in a specific date and add in, let's just say if we want to go back to the 12th, between the 12th and the 13th. We can do that and compare those as well, and add those different pieces to our metrics there. Now the last option I want to talk about here is metric anomalies. And what we can do with metric anomalies, of course, this is different than anomalous metrics. We're talking about metric anomalies here, which is a breach in the dynamic threshold for a particular metric or a certain period of time, whatever we've got set on our date controls. Now what we can do is look for in our metrics here, we can see a little bit of yellow underneath some of these metric categories. And that yellow is letting us know there are some metric anomalies there. So if I open things like cost here, we can see daily additional cost, effective month-to-date cost, and month-to-date total cost have got these yellow bullets here. And that's letting us know right now there is a metric anomaly going on with these particular metrics. So let's go ahead and just open a couple of these here. Let's see, virtual machine used, and actually I want to see provision space as well. Looks like on virtual disk here, there's something going on used disk space. All right, let's go ahead and check on and pull all these metrics out. So now we've got some metrics opened up that we wanted to look at, and some of them, we can see are kind of trending upwards. But let's go ahead and turn on first of all the metric anomalies, or this is our anomalies button. Let's go ahead and click that. So now we get exactly where these particular metrics are breaching their dynamic thresholds. So we can see there are multiple times here throughout. Right now we have the last 30 days up. So within the last 30 days, there are multiple times these have breached their dynamic threshold. Now that dynamic threshold is probably recalculating since it calculates every 24 hours. We know that, that's probably where we're saying, all right, right here at the end of this yellow period, we can see that anomaly. It's probably recalculating that dynamic threshold and saying, well, it's now kind of within that threshold because we've recalculated it. And then again, it will break that again. It'll break that threshold, and then that's where we get those metric anomalies. Now we can go ahead and find out exactly when this happened, right? If we click our dynamic thresholds and turn those on, now we can see exactly what happened there with the dynamic threshold. So we did have, so for month to date cost, we can see we were in that dynamic threshold, and then boom, right here, we broke that threshold. So we're above that, and it's letting us know that is now a metric anomaly. It is an anomaly because we've broken our dynamic thresholds, but they are recalculating. So again, we can see if we zoom in a little bit here, we can see we've recalculated our dynamic threshold. It goes from lower to higher, and now we're back within that. And then our metric for virtual machine, our disk space used, has jumped again above that threshold again, and we had to recalculate it. It looks like I recalculated it, but it's letting us know it did break that threshold, and now we're above it. So we're kind of using all of our different options available to us. We're looking at anomalies. We're using our dynamic thresholds. Reset the zoom real quick here. And we can even use our trend line again and see what our trends look like. So we've got our trend line going up for, CPU average daily usage, that was already there. We can see our trend line going up here for our month-to-date cost. It's going up on our disk space. It's going up on our provision space for the VM. It's going up on our used disk space from the virtual disk. So we can say there probably is some correlation there. Our cost is going up because our storage space is going up. So what we're using versus what we're provisioning is also increasing our month-to-date cost. So we can kind of make that correlation there, which is going to be our next topic, is talking about metric correlation. All right, so metric correlation. We can see there's a button here on each and every one of these charts that says correlation. And what vRealize Operations Manager is doing here is matching patterns for the selected metric. And either that's directly or inversely. So going up, it might correlate with something else going down. But really, there are two ways we can do so. And there's actually a third way that we'll talk about when we get to the Troubleshooting Workbench in a few minutes. But for now, from our metric charts, there are two ways we can do this. We can either look at self-metrics, or we can look at the metrics of all of its peers. So self-metrics is going to look within the specified object. In this case, we've got a virtual machine. It's going to look for other metrics that might be following the same pattern as the one we selected. And the other option is going to be for peers. So it's going to look across other virtual machines here in the selected navigation tree that we're in, and see if there's any sort of metrics that go along with that on other objects. For now, we're just go ahead and click the self metrics. We've got our average daily usage on CPU as our baseline. And we're going to look for other metrics that might match that similar sort of pattern that we have going on. So once we've got those pulled up, we can see, all right, we've got our effective projected total cost. We've got our projected total cost. We actually already had those pulled up. We go down here. We see an inverse relationship with the consumed average daily amount of memory, as well as we're looking at disk space and disk space for the VM, as well as the provision disk space, which we've already got up as well. So this is looking across. It's noticing that upward trend or a downward trend in the state of memory and matching these together. Now we already have these pinned. There is a pin option, but we already have these. Most of these metrics we've got pulled up, we've already got pinned. Now, if we wanted to do it the other way, then let's go ahead and say, let's look at the month-to-date total cost of this VM and compare it with others as well. So now we can see we've got our month-to-date cost here for our baseline VM that we're looking at. But we can also see a few more VMs that are also experiencing this uptick in total cost. And if we wanted, we can say, all right, here's a load gen, here's maybe our database. Let's go ahead and pin these as well. Let's pin both of these two, since it looks like we've got our front end, we've got our load gen, we've got a database as well. So maybe these are probably connected in some way. So we've got those now pinned. We can see those at the bottom here. We've got them pinned. So now we can look at all of those metrics together. We can see if we're breaching any dynamic thresholds. We can look at our current trend lines, which are very similar to what we're using for our baseline. Now the last option here is looking at generating dashboards. So we can say, all right, I want to look at these particular VMs and all the metrics we've got there. And now we're just going to create a dashboard from that. Maybe we want to look at those a little more closely for future reference. And now we've got a dashboard that we can go to if we wanted to look at these VMs for future reference. Let's go ahead and pull that up real quick here. So there we go. We've got all of our metrics from one of our baseline VM, as well as the metrics for the other VMs we pulled in. Now we can also have the same options available to us that we did in the metric chart or metric picker view. We still can look at our trend lines, our anomalies, our dynamic thresholds, only now we have a dashboard that will persist in perpetuity or until we decide we don't need to watch these particular VMs any longer. Now we can also add further things here. If maybe we want to add topologies, or we can add any other widgets when we're customizing dashboards for these particular VMs, and we'll get all that information just on one dashboard. Now the next thing I want to talk about is the Troubleshooting Workbench. Now, the Troubleshooting Workbench is where we can take any vSphere object or any object that is in vRealize Operations Manager at the time. We can take a specified time range, a specified scope, and take a look at our events, our property changes, and anomalous metrics with a tab for each of those so we can dive a little deeper into that specific object. There are multiple points we can launch this Troubleshooting Workbench from. We can either do that from the Home tab on the Troubleshooting card or the Navigation menu. We can do that from any alert on the Potential Evidence tab. And we can also, from the Object Summary page, we can see the little Troubleshoot button at the top. We can click that to launch our Troubleshooting Workbench. So what we're doing is taking that specified time range. We can change our time range out. We can on the left side we can see we can change our scope out, so we can have a full stack topology to look through our problem scope. We can set a custom scope, and we'll get into that here in a few minutes. And then we're going to look at the potential evidence across our object with events, any configuration changes, or anomalous metrics. So let's take a look at what those are exactly here. So our events is going to be taking our events. An event would be anything that has crossed one of those dynamic thresholds we talked about earlier. So it's not necessarily going to take into effect our hard thresholds, and we'll talk about that in a moment. But anything that is outside of the usual behavior for that object will be listed as an event. It's going to take in any sort of property changes, so configuration changes that might have occurred within the selected time range that we've chosen, within the selected scope that we have. And that can be single or multiple property changes that we wanted to look at. And then anomalous metrics, so metrics that have a more drastic change within that time scope or time and scope. This is going to rank the results here based on a degree of change, and the most recent ones are going to be given the highest weightage here. So let's take a look at the first two. Let's dive a little deeper into that. The first two parts being events and property changes. So we're going to take our events, we're going to subtract out again those hard threshold violations. We're only looking at dynamic threshold violations here. And then we're going to take out anything that has a positive sentiment attached to it. So anything that's success or restored, or some good examples, those are going to be taken out, so we're not going to look at those, even if it does technically breach any sort of dynamic threshold. But if it's a success or restored, we're taking those out. And then it's going to be assigned a ranking, and it's going to be based on info, warning, immediate, or critical levels for that particular event, and then further weighted on what the current state is, what the start time, and how many times or the frequency that particular event might have happened. Now, property changes are also going to look within, again, our time range and scope. And now, if an object was created during our time range, though, we are going to take that out. If we went from nothing on a particular object, and then the object gets created, and now we have everything, configuration-wise, that is going to result in technically a new property change, and therefore it's just going to put everything in there for a particular object. So we take out new objects. We know that could create some sort of noise, and we know noise can be easily ignored. So we want to take out those new objects, and we're only going to take into effect objects that have been here for a certain period of time. Then we're going to take all of those priority or the property changes. We're going to rank those based on the time and the proximity to the end of the time range. So the closer to the end of the time range we've selected, the higher that's going to be weighted. And then if there are multiple occurrences of a property change, that the ranking is going to be decreased a little bit for multiple occurrences of that. Now, I want to take a minute again to mention the difference between metric anomalies and anomalous metrics. We mentioned this earlier, but we didn't go too deep into it because I wanted to get into the concept first of anomalous metrics. So a metric anomaly is going to be whenever we've breached that dynamic threshold or we have a violation of our dynamic threshold, and that's going to show up in the events section of our troubleshooting workbench. Anomalous metric, again, is going to be we have a drastic change in our metric. So not just a quick blip or a quick spike. This is something that has made our metric so it is completely different than what it was before. So we did it in previous versions of vRealize Operations. Before we had this Anomalies badge, which showed the number of metric anomalies. That's not really the concept any longer, but we wanted to get some clear up the confusion between these metric anomalies badges, which is no longer used. Those are on older versions of vRealize Operations. Metric anomalies, which again, dynamic threshold breaches, and anomalous metrics, large changes. So we know those events are dynamic thresholds. We know anomalous metrics are going to be drastic changes there. Speaking of anomalous metrics, this is kind of how we calculate. On the back end, we're using Pettit's test for change point detection. There's a lot of math that goes into that. I'm not going to get into that today. However, the part that is kind of what we want to look at is the part in blue underneath the picture there. Metrics are considered anomalous if they result in a change of the mean of the data points for each window. So that a change in the average of the data points for our time range will result in something being considered anomalous. So there's a sliding window that's going to go through and calculate the average for our specific time range, and if we have a difference in our average, that's when we're going to say, okay, this is now anomalous or an anomalous metric. Now, for our best results, we do want to set that time range for 6 hours or more. Doesn't mean it won't work in a smaller section of time, but the longer period of time we have, the more a large spike is not going to affect our average as much. When we have this short time window, our results could be skewed just because one spike in only a few data points, one spike could change a mean fairly easily. I do want to point out as well, there is a logs tab within the troubleshooting workbench, and this does have automatic log filtering here. So if we went to our logs tab, it's already filtered directly for that object we're already looking at. So there's nothing extra we need to do here if we have that integration with vRealize Log Insight already set up. The last thing to point out here is that we can have multiple troubleshooting sessions going. If we go to that troubleshooting workbench, we can search directly from there. So if we have an object that we want to look for specifically, we can search for that. Any sort of active sessions are going to be under active troubleshooting sessions, and that persists through your login. And then if there are searches that have been done previously, we'll notice those at the bottom under recent searches. If it's might be after the login that we started it in. All right, jumping back into our demo environment here, we've got a virtual machine that we know that there's some sort of issues with or some sort of challenges we need to look at. I've pulled up just a virtual machine here. We're looking at the last 6 hours, and we're looking at only this specific virtual machine. and it's letting us know there's not much potential evidence for this scope and time frame. So we might want to change that if we want to look at any of the challenges we're having. So we can change our time range here. We can change that last 6 hours, 12 hours to 7 days, or we can specify a custom date to another custom date if we wanted to use that as well. Now, if we also look at over here on the left, again, our scope. Now, right now, we're right here in the middle. We're looking at only this particular virtual machine and none of its relatives, whether that be parent or children relationships. But we can customize that a little different. We can click on different levels. We can click on our plus sign here and start adding in one level above, one level below. And now we can see metrics are going to start coming in here, our events and our property changes and our metrics. So we can look through at these, at what might be going on. We can also change our scope using a custom scope. So I'm going to click on that custom scope. And right now, we're already at one level above the VM and one level below. Now we can add in the various things we want to add in. Maybe we would add these disk groups. Maybe we want to add in some things off of our host there. Looks like we've got some switches. We've got our vSAN cluster. Okay, I think that's good for our custom scope. We could always keep going if we wanted to go out further away from that particular virtual machine. So if I click on that, now our custom scope, now we've got a custom. We could always jump back into it. We could reset that. We could reset it and then add levels further from here as well. Now we've got some changes we can look at from our events or anything that's breached our dynamic thresholds. We've got one property change here in the memory capacity of our looks like of our host. We can look at our cluster and look at what is going on with that. Under anomalous metrics, looks like we've got some increase to our costs overall here. Now what we can do is with these anomalous metrics is just say, all right, I want to go ahead and I'm going to pin this particular metric. And now that little blue dot popped up next to our metrics here. And now if we jump to that, we can see we've pinned that metric there. And now we can do the third of our correlation features. Using our correlation, we can take this correlation by scope. And this is going to take all of our metrics that are in the same scope that we're using here for our troubleshooting workbench session. And if we change that, let's see what pops up here. We've got a couple other things we could look at. It looks like some alerts that we can look at as we go through within that same scope. The next thing I want to talk about here is our near real-time collection. So what we can do is go to our administration tab, click on our vCenter, and what we can do is see that there is an option here for near real-time monitoring. We can enable that, and with that enabled, we now have the ability to collect from our vCenter server every 20 seconds instead of the default 5 minutes. So what this is doing is allows us to look at any sort of rapid or short-lived changes to our environment. We're going to get this 20-second collection for metrics, properties, and events. So we can evaluate our event-based symptoms here in near real time. We do collect this information. Will be stored for 3 days, and then it will be deleted after that. Mainly just we don't want to have too many metrics that are being stored for a longer period of time. It's going to increase our storage by a lot if we did that. We can also edit any sort of symptom definitions to evaluate on our near real-time data if we wanted to do that. And this is basically to avoid alert storms. This is not on by default, but we can turn this on for our symptom definitions so we can get those alerts in real time as well. So what we can do is I'll go ahead and I want to search for a specific, actually that is the VM I want. So let's go ahead and search for this VM, and let's see if this is collecting, and we'll see how this works here. So if we go to our metrics tab, as we've already discussed before, I'm going to bring it up. We'll look at our CPU here, and really I just want to look at, let's look at a couple of things. Look at our demand percent, our ready, and maybe our usage here. So we can see what these have looked like over the past, looks like just from since yesterday. So we're looking at the last 24 hours. And this is right now is on the 5-minute default collection cycle. So we can see we've got, it looks like a couple places in here that we can probably look into and see what those look like. I'm going to go ahead and, well, let's see, I'm going to zoom in all of our charts, since we know what that option is there. I'm going to zoom in here for a couple hours, right in the middle of this kind of spike, and see what we can find out. So looking at our 5-minute collection cycles, we can see it looks like fairly even, fairly flat. Everything is pretty. Doesn't look like anything is going too high or spiking anything. But if we see this option right here, where we can turn on our near real-time data, and now we can really look and see every 20 seconds rather than every 5 minutes what these particular metrics look like. It'll zoom us in again. Now we can see it wasn't necessarily that each of these metrics was completely flat, but it looks like a series of kind of mini spikes that go up and down as we go through our demand, our ready, and our usage. So what our usage looks like just spikes every once in a while, and then it's back almost zero there. So that just kind of helps us. We can get that quality of data, or get the dive a little deeper into our data. So now what I want to do is go ahead and take all of the pieces we've just learned about and tie those all together in kind of a scenario that we have set up here. So we're going to go ahead and run through this scenario and jump into this demo here. So just from our homepage of our of vRealize Operations, we're going to click on Dashboards here and bring up our dashboard that kind of has our shopping cart application. So kind of a generic shopping cart application here for a company. Maybe they sell hand tools or power tools, hammers, all that good stuff. And this has got a web tier. It's got our database tier, so we can see our front-end VMs here, as well as our database VM. Now, if we're looking at just the overall health of our application, it's noticing that it is down at this point, down to 25%. So we have 25% health. Obviously not great when we're looking at the health of our application. If we look at our tiers, we can see, okay, it looks like the database tier is actually what's giving us an error, or giving us not necessarily an error, but an alert, and letting us know that database tier might have some challenges we need to look at. Now there's a few things on the web tier here, so a few warnings on the web tier we might want to look at as well. But for now, we want to look at the database tier that's running here. So we're going to click on that database. We can see quite a bit of green here: CPU contention, memory contention, latency. A lot of things are green, but we do have this CPU demand that is spiking up on us. We're up to 116%. Obviously, that means we're using, or if we gave the CPU unlimited amounts of CPU to the VM, it would need at least 16% more than what it's using now, or what it has associated with it now. So we want to check and see a little bit further into this and see what that alert is as well. Let's go ahead and check on the details for this particular virtual machine. So we can see, yep, the virtual machine is in fact red here. We've got a critical alert. And since it was on CPU, I want to take note of how many virtual CPUs we have configured for this particular virtual machine. So we've got 4 at the moment. I just want to kind of take note again of what that is. We can also see that alert is letting us know that our CPU usage is at 100% for an extended period of time. So that is obviously has to do with our CPU demand. Right, we're at 100% usage, and in fact, we could use at least 16% more CPU out of that. So let's go click in further and into that alert and see what we have here. We already know it's at 100%. Here's the recommendations for us, so letting us know, all right, what is it we can do to maybe get a little more information from this, maybe check and see what's running. And so it says check our processes running in the virtual machine and see if anything is hung or needs to be restarted. And this is something we hadn't gone over as of yet, but we can, right from vRealize Operations, go ahead and click our Actions button at the top here and get our top processes, so we can see what the processes running on the OS here, what those are. So we can get a number of processes, whatever number we'd like to grab from this. 10 is fine for the moment. We just want to see the top processes that are running. We click that Run button, and it'll come back and let us know, all right, we do have MySQLD that is running at 400 CPU. Since we already kept track of what that was, we put it in our head as far as we have 4 vCPUs configured, so we know each of those is taking 100%. So we already kind of knew that our CPU was spiking, but now we know for sure that it is MySQL that is taking up all that information, or taking up all our CPU room there. So we want to, at this point, let's go ahead and check and see if we can find any additional potential evidence. This is sort of a mini troubleshooting workbench. So to kind of right from here, without even launching the workbench, we can see a little bit of information. We can see our events, our property changes, and our anomalous metrics as well, if we scroll down there as well. So one of the things we're coming up is letting us know here that our CPU workload percentage is showing as an anomalous metric. And we know already that means that there's been a drastic change in that metric over what it had been previously. So we can see coming into about 9:05, we started spiking up. That actually was yesterday, today, and then it just kind of stays up. And so we've got a change in the mean there on that CPU workload. So what we would probably want to do is go ahead and launch our full workbench here, so that we can dive a little deeper and check out that this particular virtual machine here. So we already know, we need to be able to change our scope. We need to be able to change our time frame. Otherwise, we're just looking at noise. Right now, we're within the troubleshooting workbench. We've got just about 3 hours from 7:35, or 2.5 hours to 10:05, and we know that this works best when we're looking at least a 6-hour time frame. So from our custom range, let's go ahead and change that to a 6-hour period. So let's get the last 6 hours and see what we can find out here. So under events, we've got DRS. Looks like I'm moving some things around. That's both the host and the VM there. So DRS probably not changing a whole lot. We've got our write throughput is going down a little bit at the moment. So we might want to check into that as well. So we also are at this point looking at our virtual machine as the kind of the baseline here. So we can see one hop up, one hop down. We've got our data store. We see the host. We see our services. So we know MySQL. We already checked that on our top processes. We already knew that was there, as well as that is a Linux OS here. Now I want to go ahead and extend my scope out so I can actually pull in the database that's running here. So I'm going to hit that plus button, and now we can see I've got MySQL. We've got our shopping cart we were looking at before, as well as now I've got some HTTP checks that we're showing as running as well. So we can now go ahead and look through these metrics and see if there any of the other metrics might be anomalous here as we go through. Sure enough, if we scroll down, we've got our number of threads connected, as well as our total connection count to that to our MySQL, our shopping cart DB here. So that's something we would probably want to go ahead and let's pin that metric there. And if we pin that, we can see that a little dot pops up next to our metrics, letting us know that there is something that has been pinned there. Let's click on that metrics tab. There's the connection count we just pinned. And now from before, we know that if we're looking at all of our metrics here, this has got this yellow diamond here letting us know something might, there's some sort of anomaly going on there with that as well. So let's open that up. Sure enough, our CPU usage and demand are both showing as metric anomalies there. So now we can see, along with our connection count here, our CPU usage was running along about 95% on the usage. And then at some point, right when our connection spiked up, our usage went up to 100%. That's why we fired off that alert in the first place. And of course, our demand went up as well, but it went higher because the virtual machine really would be using more CPU if it had it. So let's, we probably want to go ahead and change this here and change our CPU count for this particular virtual machine. So we're going to go back up to the top, click on the little link so we can get back to our summary tab here for that particular virtual machine. This is our MySQL virtual machine, and I want to change this CPU count since it doesn't look like at this moment that it has enough, that it can't really run the way that it needs to. So if we can go down, we've got our actions, we've got our CPU count for this VM. So we click on our CPU count. Now it's a new CPU. Well, the minimum to add is one new virtual CPU. I always like to run in even numbers. I think a lot of people do the same, so nobody really adds just to 5, I don't think, but that certainly is an option if we want to do that. And since in this case we're spiking up, we want to get this done in a hurry. We want to go ahead and add the power off allowed. We might not always have that option. We would have to wait for some sort of change control, time frame or something like that. But in this case, we just want to get this back up and running. We need it to run well. We need to be able to handle all the workload that's coming in, and we're going to go ahead and begin that action. So now we know we've changed that here. Now we want to make sure though that we're what we've done is actually helping. What we've done is making things better. So I'm going to go back here. Let's go to our alerts, and this alert will clear at some point when we get our CPU usage back down below 100%. But we want to make sure before we get there, before it clears out, that what we want to make sure that what we've done is making a change. So I'm going to go back to our troubleshooting workbench here, and we've still got all of our, we've got one hop up, one hop down again, so we've got our data stored in the host. I just want to see, since our challenge was on this virtual machine here, or the challenge we were facing was on the virtual machine itself, I only want to look at anything with the virtual machine. So I'm going to change that scope back down to level 0, which is only getting information directly from our virtual machine. So we've got that down there. Now we're going to go ahead and check on our anomalous metrics. We can see our write IOPS there. We can see total IOPS. We can see it looks like the CPU queue here has actually dropped pretty dramatically here. So our kind of queue on the CPU has dropped. So I'm gonna pin that metric there. Because I want to look again further into it. So let's we've got our metrics popped up here. Again, let's go to our metric tab. There's our CPU queue that we can see was pretty high at one point there, and now we've got it dropping way back down as soon as we added more CPU to this virtual machine. So we've got that there. Now we can use again what we talked about earlier as far as correlating metrics here to see if any other metrics have done the same thing as far as either drop down, kind of drastically like the CPU queue did, or inversely, meaning if anything went up. Not necessarily a bad thing, but it depends on what metric we're looking at here. So I'm going to drop this down. I'm going to click on correlation, and then I'm going to get all self metrics. I just want to correlate with anything that's on this particular virtual machine at this point. So we can see our CPU demand. Already we can see has dropped down here, but I want to go ahead and let's pin our CPU demand here, and let's look for any other metrics. Oh, there's our write IOPS again. We just kind of briefly looked over that, but our IOPS are kind of going back up. So we were kind of chugging along on IOPS, and then all of a sudden the amount of data we can write, our write IOPS I should say, the amount of data we can write has dropped. Because of that CPU challenge we were facing. Now we're able to write more data, and so our write IOPS is going back up. It's back on the swing. We can push more data here. So I'm going to pin both of those, and let's pull that up. And now we can see, yep, these look pretty related here. We had our spike in CPU, we had our spike in connections, our connection count, and then we've made our changes. We added our CPU. And now we're dropping both on CPU queue, our demand, and our IOPS are able to go back up. So now we can take this information and we can say, yeah, what we've done, the change we've made, has made a positive change in overall in our virtual machine, and we can see if everything else clears up. Make sure that alert clears out. We could also go ahead and, as we talked about before, go ahead and generate a dashboard here and give that to our app owner. Let them know, hey, if anything goes here again, if anything spikes on our CPU, or if our IOPS start dropping again, we can use this dashboard to see that information, see what's happening with our network, or not network, but our virtual machine, our application, and get ahead of that just in case anything starts spiking up again. So that concludes this section of the School of Ops. I hope you found this video useful so you can go out and troubleshoot like a pro using vRealize Operations Manager. Thanks for joining. I hope you have a great rest of your day.